two persons A and B leave simultaneously from X and Y. They leave at the same time to meet somewhere on XY. Okay. Speed of A is SA. Speed of B is SB. And by now, by the theory that we have seen so far, you should be able to solve all these questions very easily. Pause and give them a try. Also, there is a fourth and most interesting question at the end of the video. So watch till the end. Let's see them one by one. As we have not taken any numeric values, answers that we'll be getting will be in terms of SA, SB and D. And many a times these answers are presented as direct formulas in certain books. I suggest you not to mug up anything, not to mug these as direct formulas, just focus on the logic. So our first question is, when and where will they meet? Let's say they meet at point P on XY. Okay. So from leaving to meeting, time taken by both A and B is same. They both leave at the same time, and when they meet, they both must have traveled for the same duration, right? So time taken by both is same, and when time is constant, we can say distance will be directly proportional to speed. So ratio of distance, that is xp is to yp, would be equal to ratio of their speeds, that is SA is to SB. And we know that total distance, we know that xy is equal to d. So we can divide distance d in this ratio to get xp and yp. xp will come out to be SA upon SA plus SB into d, and yp will come out to be SB upon SA plus SB into d. So that's where they will meet. Distance xp is this, distance yp is this. They will meet at point P. Now, second part of this question is, when will they meet? As they are moving towards each other, their relative speed would be SA plus SB as they are moving towards each other. And distance, the total distance between them is d. So time taken to meet would be total distance d upon relative speed, that is SA plus SB. Okay. When will they meet? They will meet in this much time. Next question. Find the ratio of time taken by A and B after meeting to reach their opposite ends. After they meet at point P, A will be covering PY. Okay, A will leave in this direction to cover PY, and B will be moving in this direction to cover PX. So we have to find time taken by A to cover PY upon time taken by B to cover PX. This is what is asked in the question. Ratio of time taken by A and B after meeting at point P to reach Y and X respectively. A will be reaching Y and B will be reaching X. So this ratio is what we are going to find. This distance XP and PY we have already calculated in the first question. We are going to use it here. Now time taken by A in going from P to Y. Time taken by A in going from P to Y would be distance PY upon speed of A. Okay, PY we have calculated in the first part, that is SB upon SA plus SB into D. This upon speed of A. Okay. This would be SB into D upon SA plus SB into SA. Similarly, time taken by B to cover PX would be PX upon speed of B. PX we have calculated in the first part, that was SA upon SA plus SB into D. So Px upon SB will come out to be SA into D upon SA plus SB into SB. Okay, this was first equation, this is second. We have to find this ratio, so we'll divide these and get the ratio of TA to travel Py and time taken by B to travel Px. This ratio would be, divide these values, D and D will get cancelled, SA plus SB will also get cancelled, and we will get SB square upon SA square. So this this result is often given as a direct formula in books. You need not remember it. You can easily solve it this way. Next, if they move to and fro between X and Y, to and fro means A will go from X to Y, then back to X, then back to Y, and like this it will continue. Similarly, B will go from Y to X and then back to Y, then again to X, and so on. So let's see how they meet. Their first meeting happens at this point P. So when they meet for the first time, A came from X to P and B came from Y to P. So together, both A and B together, they must have covered D distance in order to meet here at P. Right? This XP plus PY is D only. Total distance is D. So in order to meet for the first time, they together covered D distance. Now we will talk about second point of meeting. To meet for the second time, B will go in this direction, B will reach towards X, and A will go in this direction, A will reach towards Y. Okay, so in order to meet second time, B will go like this and will return from X. A will go like this and will return from Y. Okay, so basically B will have to reach from P to X. B will be covering distance Px, and A will have to reach from P to Y. A will be covering distance Py. So in order to reach opposite ends, both A and B together will again be covering distance D. Okay, they will again be covering distance D to reach these opposite ends, and they will return from opposite ends, and let's say they meet somewhere here at point Q. They meet here at point Q. So B will be returning from X and B will come from X to Q. A will be returning from Y and A will come from Y to Q. So this distance till opposite ends is D, and then again B will be covering XQ and A will be covering YQ. XQ plus YQ is again D. So in order to meet for the second time, they will be covering this total distance D plus D plus D, that is 3D. Okay, for the first time when they meet, they cover distance D when they meet at P, and then when they meet at Q, they cover distance 2D more to meet at Q. So for the first meeting they cover distance D, for the second meeting they cover distance 3D, and for each subsequent meeting they have to cover 2D distance more than the previous one. Okay, they will be covering 2D distance more than the previous one. So we have their first meeting and total distance and time taken to meet. Okay, and first meeting they cover total distance D. In second meeting they cover distance 3D. In third meeting they cover distance 5D. Similarly, to meet for the nth time, for nth meeting, they will be covering distance 2n minus 1 D. Okay, these are all odd numbers. Looking at the pattern, we can say for nth meeting, they will be covering distance 2n minus 1 D. And if we talk about time taken to meet, their relative speed is SA plus SB as they are moving towards each other, or even if they move away from each other, their relative speed is going to be SA plus SB. So time taken would be D upon SA plus SB. For the first meeting, it would be 5D upon SA plus SB for the third meeting, and for nth meeting, time taken would be 2n minus 1 D upon SA plus SB. So this would be the time taken by the two men when they meet for the third time. This is the time taken by the two men when they meet for the third time. Okay. Then we have to find distance ratio when they meet for the third time. What is distance ratio? Out of this total 5D distance that they travel to meet for the third time, we have to find ratio of distance traveled by A upon distance traveled by B. In the beginning, they leave simultaneously. Then every time they meet, be it for the first time at P or be it for the second time at Q, every time they meet, they would have traveled for the same duration. They would have traveled for the same time, as they start at the same time and they meet at the same time. So obviously for meeting, they must have traveled for the same duration. So time is going to be constant for both of them every time they meet. So even when they meet for the third time, distance covered by them individually will be directly proportional to their speeds. So distance covered by A and distance covered by B, this ratio would be same as ratio of their speeds, as time is going to be constant whenever they meet. This will be true for any number of meeting. Okay, distance covered individually by A is to distance covered by B. For 7th meeting, for 8th meeting, for 9th meeting, it would be SA is to SB. The ratio would be same. Next, last but not the least, we have a slightly different question. Their speeds are not given here. All we know is that A leaves X at 5 p.m. and reaches Y at 7 p.m. B leaves Y at 5 p.m. and reaches X at 8 p.m. So basically A takes 2 hours to cover XY distance. A takes 2 hours to cover distance D and B takes 3 hours to cover distance D. They both cover D distance in order to reach opposite ends. So distance is constant for both. And when distance is constant, the speeds will be inversely proportional to time. So ratio of time taken by A to cover distance D is to time taken by B to cover distance D is 2:3. This ratio is 2:3. And when distance is constant, distance is D for both of them, we can say ratio of speeds. Distance is constant, so speeds will be inversely proportional to time. Ratio of speeds would be 3:2. Okay, this we have written considering D as constant. Okay, and these two lines, we have written these two lines by looking at their journey towards opposite ends. Okay, when they reach opposite ends. Now when they meet, let's say they meet at this point P. When they meet at point P, they started together at the same time 5 p.m. and they meet at the same time. So they would have traveled for the same duration when they meet. Okay, this is clear. So when they meet, time taken by both would be same. Okay, it would be same value for both. When time in two cases is same, when time in two cases is constant, distance would be directly proportional to speeds. So distance traveled by A and distance traveled by B to meet would be directly proportional to speeds. Distance traveled by A to meet would be XP. Distance traveled by B to meet at P would be YP. So XP is to YP would be, as time is constant, this ratio would be same as ratio of speeds. XP is to YP would be 3:2. Okay, this we have written assuming time taken to meet as constant. This was going to the opposite end scenario. This is meeting at P scenario. Okay. Now forget B for a while and simply focus on A. A starts from X, goes at a constant speed, passes P and reaches Y. Speed of A is constant throughout this journey. Nothing is said about A changing its speed in between. So it is constant throughout. Okay. So when speed is constant for different patches of journey, time taken to cover those patches will be directly proportional to the distance. When speed is constant, time will be directly proportional to the distance. So we can say time taken to cover this patch xp, time taken by A to cover xp is to time taken by A to cover this whole distance d will be equal to, this will be directly proportional to the distance. Xp is to x y. Why? Because speed is constant now. When we are focusing only on A's journey from x to y. So from here we can say Txp upon Td, time taken by A to cover d distance, is 2 hours. So Txp upon 2 will be equal to xp upon xy. Xp upon yp is 3:2. 3:2. Xp upon yp is 3:2. So xp upon xy would be 3 upon 3 plus 2. This would be 3 upon 3 plus 2. So from here we can say Txp would be 3 by 5 into 2, that is 6 by 5 hours. Okay, this we have written focusing just on A. Focusing on A. So this is 6 by 5 hours. 6 by 5 is 1 by 5 hour, that is 1 plus 1 by 5 hour, and this would be 1 hour plus 1 by 5 hour could be converted to minutes. 1 by 5 into 60 minute. 1 by 5 into 60 is 12. This is 1 hour 12 minute. That means A and B meet at point P in 1 hour 12 minutes after 5 p.m. So they meet at 6:12 p.m. This is the final answer. Okay. When will they meet? They will meet at 6:12 p.m. And where will they meet? Well, xp is to yp is 3:2. This ratio we know as 3:2. Total distance is d. We can divide distance d in ratio 3:2 to get the value of xp and yp. Okay. So we have used proportionality of all three, speed, time and distance, in this single question. Okay. First of all, we found the time ratio by their leaving and reaching time. We found the time ratio as 2:3. Then to reach opposite ends, both will cover distance d. So keeping distance d constant, we got the speed ratio as inverse of time ratio. The speed ratio came out to be 3:2. Then when both were meeting, time they traveled till they meet will be same for both of them. And as time is constant, distance will be directly proportional to speed. So we got distance ratio same as the speed ratio, that was 3:2. And lastly, we only considered A's journey alone for these different patches xp and xy. So A's journey alone, for A's journey alone, speed of A was constant throughout. So time taken for these patches, for these parts by A would be proportional to these distances. So xp is to yp is 3:2. Time taken in these distances would be also same as xp is to xy. So time taken by A to cover xp came out as 6 by 5 hours. In same 6 by 5 hours, B will be covering yp to meet A at P. So after 5 p.m. they take 1 hour 12 minutes to meet. So they meet at 6:12 p.m. There are many ways to solve this, but this one is the fastest as there is more thinking and less pen and paper. And speed of thinking is directly proportional to the practice you have done. So start practicing. A little exercise for you in this question. Solve the same question when A leaves at 3 p.m. instead of 5 p.m. Okay, now solve the same question. Everything else is same. Put your answers in the comment and we'll discuss it there itself. Thank you.